This last problem that was in our packet, I want to include in the video, but I strongly recommend you try this problem on your own before you watch me do it. The practice and the things you might bump into would be really great for you. So pause the video, go try it. Once you tried it, finish watching this. Okay, so the question says, find the value or values of k that make this equation true. There's something implicit here. I want to clarify the statement here, clarify the question. It's asking you to find k such that the left-hand quadratic is identically the same as the quadratic on the right. What would that mean? That would mean no matter what x value I put in, I want the left and right-hand side to evaluate to the same number. So I need to get the left-hand quadratic to have the exact same coefficients as the right-hand quadratic if I have it in standard form. What will be helpful is getting this in standard form. There's more than one way to do this problem, by the way, but I'm doing it in a certain way that would generalize to any similar problem I could give you. So let's do it. So first, the left-hand side is of the form a plus b squared, and that you need to memorize so that it is automatic, is this. Now, if we multiply out the left-hand side, we get a squared plus 2ab plus b squared. Notice how I wrote out parentheses for where the a's and b's go, and now I'm just going to go back and plug a and b in. It's a really safe way to make sure you get your minus signs right and you keep everything straight, especially when there's more complicated cases. 3kx, that's a squared, and then in here I put ab. 3kx times 2 times 2. A squared plus 2ab plus b squared. Right-hand side, I'll just write it out. I'm going to keep simplifying my equation. Left-hand side would be, of course, that power of 2 applies to every factor inside the parentheses. So 9k squared x squared plus 2 times 3 times 2 is 12kx plus 4 equals 81x squared plus 12kx plus 4. Okay, so I'm noticing a few things here. First, I'm noticing that I have my constant as 4 and my constant as 4. That's great. That means it's possible for the left and right to be identical. I notice I have 12kx and 12kx. So this coefficient needs to equal this coefficient, but that's going to be true no matter what k is. So that doesn't really help us solve for k. But this one, 9k squared and 81, 9k squared needs to equal 81, and now we're getting somewhere. So divide both sides by 9, k squared equals, I'll do this two ways. I will preview future things we're going to cover. Right now, there's two ways to solve this. The short way, because it's a perfect square, is the following. Divide both sides by 9. I get k squared equals 9. Now I can take the square root of both sides of the equation. Whenever you do that, hopefully you've seen before that you need to consider the plus or minus case. So k equals plus or minus the square root of 9. K equals plus or minus 3. So those are our answers, by the way. K can be plus or minus 3. And there is another way, just looking forward to the future. I can divide both sides by 9, and I get k squared equals 9, just as I did before. I could subtract 9 from both sides. And now I could apply my factoring rule. A squared minus b squared is the same as a minus b times a plus b. Well, 9 is 3 squared. So the left-hand side is k plus 3, k minus 3 equals 0. the zero product property says that if I have this times this equal to 0, then either this is 0 or k minus 3 is 0. Remember, or means union. So I'll take the solution I get from this equation and the solution I get from this equation, put them together into one set, and that's my solution set. I get k equals -3 or k equals 3. And so my solutions are, my solution set, and this is the way the book might write it, the solution set is -3, 3. And the version in green is what justifies why we take plus or minus square roots when we take square root of both sides. That's actually a preview of a future chapter. Actually, we're going to do, sorry, that's a preview of a future section in this chapter, and then that theme is going to come back a lot throughout the year as we study the fundamental theorem of algebra at a later date. Okay, all right, I will see you in class. Bye.